Let's wait up to 4 o'clock. Then we will start, okay? I will just share the slides. Is the slides visible?
Yes, ma'am.
Okay. We will start in a while. So, good evening, all. Welcome to week 1 tutorial course Introductory Organic Chemistry II by Professor Harina Chakrapani and Professor Neeraja Deshaputre. Myself, Anisha Suresh, PMRF TF for this course from IIT Bombay. So, today we will be discussing some previous year assignment questions from week 1. Before that, we will be briefly discussing the summary of the lectures that is covered in. So coming to summary of week 1, in week 1, sir have discussed regarding the essentials of enema spectroscopy and regarding electrophilic aromatic substitution reactions. So coming to essentials of enema spectroscopy, so we have discussed regarding the terms chemical shift, shielding, deshielding, frequency, etc. And we have discussed how these are affected in the spectrum. So as we can see here, chemical shift, it will be small when we are coming towards the right and it will be large when we are going towards the left. Field will be high towards the left and we will call it upfield, and field will be low towards the left and we will call it downfield. And frequency is directly correlated with the chemical shift. So when we go to right, the frequency will be low, and when we go to left, the frequency will be high. And when we tell the term shielding, so towards the right it will be shielded, that is there will be more electron density surrounded. And when we come towards the left it will be deshielded, means the electron density surrounding will be less. And we have discussed were the regions coming in the proton NMR spectrum. So as we can see here, in 0 to 3, saturated CH3, CH2, CH, which are not next to oxygens, will be coming in this region of 0 to 3. Okay. In the region of 3 to 4.5, as we can see, like OCH3, OCH2, CH3, etc., will be coming in this region of 3 to 4.5. And in the region of 4.5 to 6.5, you can see alkenes, that is protons on saturated carbons like double bonds, CH2, CH3, etc., will be coming in the region of 4.5 to 6.5. And in the region of 6.5 to 8.5, we can see protons on unsaturated carbons like benzene, aromatic protons, etc., will be coming in this region of 6.5 to 8.5. And in the region of 8.5 to 10.5, we can see aldehydes, that is unsaturated protons that will be coming next to oxygen. Okay, so for better understanding, it is good that you remember this regions of the proton NMR spectrum when we have to solve the problems related to NMR. It is good that we remember this regions. And we have discussed regarding the regions of the 13 NMR spectrum. As we can see, in the regions of chemical shift 50 to 0, we can see saturated carbon atoms, that is CH3, CH2, CH, etc., will be coming in the region of 50 to 0. And saturated carbons which are next to oxygen like CH3O, CH2O, etc., it will be coming in the region of 100 to 50. And thus in the region of 150 to 100, we can see both the aromatic carbons as well as unsaturated carbons which are next to alkenes. Okay, carbons that are alkenes like C double bond C, and aromatic carbons, it will be coming in the region of 150 to 100. And in the region of 200 to 150, we can see carbonyl peaks like ketones, aldehydes, acids, etc., will be coming in this region. Okay, so these are the two important things that we should remember while we are solving problems related to NMR spectroscopy. And we have seen how electronegativity is any doubts, Devendiran? Hello. Okay, if no doubts, we have discussed regarding the electronegativity and chemical shift, how electronegativity of atoms will be affecting the chemical shift of proton and carbons, that was discussed. Then we after discussing the essentials of NMR spectroscopy, SAR have moved towards electrophilic aromatic substitution reaction. So mainly we have discussed regarding the Friedel-Crafts alkylation and Friedel-Crafts acylation reaction. And along with that, we have discussed regarding the Gatterman-Koch reaction. So for going for further references, it is better to follow Claydon Organic Chemistry. So you can get an insight of this topics from chapter 3, chapter 11, and chapter 22 from Claydon Organic Chemistry. Now we will go straight to the practice problems, that is previous year assignment questions. I will be discussing previous year assignment questions from previous course sessions. So coming to the question 1. Aniline does not undergo Friedel-Crafts reaction using AlCl3 because aniline will not undergo Friedel-Crafts reaction. So what is the reason behind it? So the first option that is given is aniline is deactivated due to the minus R effect of NH2 group. Aniline reacts with AlCl3 to form a Lewis acid base adduct. Option C, both A and B are correct. and option D, none of the above. So what will be the reason why aniline does not undergo Friedel-Crafts reaction? Yeah, option B is correct. Aniline, the nitrogen NH2 on the aniline will coordinate with AlCl3 and form a Lewis base adduct like this. So the lone pairs, it will coordinate with AlCl3 and it will form a Lewis base adduct like this, and that is the reason why aniline will not undergo Friedel-Crafts reactions. Okay, so the right answer is option B. Now let us go to next question. Which of the following have the correct arrow pushing sequence? So here the electrophilic nitration reaction mechanism is given. So several arrow pushing sequences are given, out of which only one is the right answer. So which is the right arrow pushing sequence? A, B, C or D? A. Yeah. The electron rich alkene will be going and attacking on the positively charged nitrogen atom, and the oxygen will be, and this double bond will shift towards the oxygen. So that is the right mechanism, and all others given are wrong mechanism. So the right option is option A. So this is the mechanism for nitration. As we can see, nitric acid and sulfuric acid uh, will be the reagents that are used for nitration. So the nitric acid, it will abstract the proton from sulfuric acid. So it will form an intermediate like this, and when this N minus will push towards here, this OH2 will be removed and the nitronium ion will be formed. This is the reactive species for the nitration reaction. Then the alkene, this alkene will go and attack at the nitrogen, positively charged nitrogen, and this double bond will shift towards oxygen, and we will get this intermediate. Now proton abstraction will be taking place in the presence of some base, and we will get nitrated benzene, nitrobenzene. Okay, so this is the mechanism of nitration reaction, and the right option is option A. Is there any doubts regarding this mechanism? Hello?
No, ma'am.
Okay. Now coming to question number 3. In practical organic chemistry, tetramethylsilane is mainly used for option A, making volatile derivatives of alcohol, option B, a spectroscopic standard, option C, a solvent for infrared spectra, option D, an anti-knock in gasolines. So we have discussed regarding tetramethylsilane in this lecture. So what is the use of tetramethylsilane in practical organic chemistry? This is tetramethylsilane. Yeah, as told, it is used as a spectroscopic standard. So the chemical shift of this tetramethylsilane will be locked at 0 ppm. So it is used as a standard or reference while we are recording NMR spectrum. Okay, it is used as a spectroscopic standard. Now coming to question number 4. Nuclei having either the number of protons or neutrons as odd have dash spin. It is given either the number of protons is odd or the number of neutrons is odd. One of this will be odd. So what will be the spin? Is it integral spin, half integral spin, zero or positive spin? I will give a hint. So here it is given, if the number of neutrons and the number of protons are both even, then the nucleus has no spin. If neutrons and protons both have even number of neutrons and number of protons both are even, then the nucleus will not have any spin. If the number of neutrons plus the number of protons is odd, then the nucleus has a half integer spin. So this sum, if it is becoming odd, then it will have a half integer spin, like half, 3 by 2, 5 by 2, etc. If the number of neutrons and the number of protons are both odd, then the nucleus has an integer spin, that is 1, 2, 3, etc. So here it is given like either one will be odd, other can be even. One is odd, one is even. So what will be the answer? Hmm? If one is odd and one is even, we can see like if one is odd, it is 1 plus other is even, it will be 2, and the sum it will be odd. So what will be the answer? Integral spin. It will be having half integral spin. Here we are not telling like both are odd. See, either the number of protons or number of neutrons as odd. Either one is odd. Hmm? If one is odd, it will follow this condition, right? Their sum will be odd. So the nucleus will be having an half integral spin. Clear? You have to keep in mind this hint.
Can you explain once again, madam?
Okay. Here in the hint it is given that if the number of neutrons and the number of protons both are even, then the nucleus will be having no spin. Okay? And if the number of neutrons plus the number of protons is odd, then the nucleus will be having an half integer spin. So the sum is odd, then it will nucleus will be having an half integer spin. And if both the number of neutrons and the number of protons are odd, in that condition the nucleus will be having an integer spin. So here they have given that it is both number of protons and neutrons both are not odd. One will be odd. So we can consider one is odd and one is even. Number of protons we can consider like 2. Number of neutrons we can consider like 3. So this is odd, this is even. So their sum will be 2 plus 3, that will be 5, which is odd. So it will follow the condition 2. If the number of neutrons plus the number of protons is odd, then the nucleus has a half integer spin, like half, 3 by 2, 5 by 2, etc. Okay? That is why here the spin will be half integral. Is it clear?
Clear, madam.
Okay. So the answer will be half integral. Now coming to question number 5. So here a compound is given This is the given compound. They are asking the number of distinct signals in the proton NMR spectrum. So how many signals will be coming in the proton NMR spectrum? Yes, Trishika, it will be C, that is 5. So we can know that this is a symmetrical type system. So here if we are labeling A, B, this will also be similar. This will also be similar. So 3 signals are coming from these 6 protons, and here one more proton will be there. That will be fourth one, and this will be fifth one. These protons will be fifth one. Okay. Hello, anyone having any doubts? I will label it with different colors so it will be easy for you to get. Do you have any doubt like this is not symmetrical? So this is a symmetrical compound. Okay, with, with this axis. So these protons will be identical. These protons will be identical, as well as these two CH3s will be identical. So 3 signals will be coming from there. Then here one proton will be there, right? Here one proton will be there, as well as here 2 protons will be there. So it will show separate signals. So 2 plus 2 signals. Total 5 signals will be coming. So this will be similar. This will be similar. This will be similar. Then comes this. And this. Total 5 signals will be coming. Any doubts? Hello?
No, ma'am.
Okay. So total number of signals will be 5. Now coming to the next question. The 13C NMR signals are in the following order of chemical shift. So here they have labeled 3 different carbons. This methyl group that is next to a carbonyl, this carbonyl, and this tetrabutyl carbon. So they are asking what will be the order of chemical shift of these labeled carbons. So we should follow the chart that we have shown in the during the starting of the lecture. The chart that is showing the chemical shift of the carbons. Largest chemical shift will be coming for B, right? Yeah, B will be the right answer. So here, this is carbonyl. So it will be coming in the range of 150 to 200. Okay, carbonyl carbons will be coming in the range of 150 to 200. So then this C, this is B. Then if we see C, it is normal saturated sp3 carbons. Okay, so it will be coming in the region of delta 0 to 50 ppm. Clear? And this A, it is next to a carbonyl similar to OCH3, OCH2CH3, which is an electron withdrawing group or electronegative group. This carbonyl is electron withdrawing group, right? So it is next to such electron withdrawing group. So its chemical shift will be coming in the region of delta 50 to 100. So that is why here the delta of B will be greater, then comes delta of A, and the delta of C will be lesser. Fine. Any doubts?
No, ma'am.
Okay. As we can see, this is the chart that we should follow. So try to memorize this chart. So the saturated carbon atoms like CH3, CH2, CH, etc. will be coming in the region of 0 to 50 ppm. Then saturated carbon atoms which are next to oxygen like OCH3, OCH2, etc. It will come in the region of 50 to 100 ppm. And like C double bond C, unsaturated olefins and aromatic carbons, they will come in the region of 100 to 150. And unsaturated carbon atoms which are next to an oxygen, that is carbonyl groups, they will come in the region of 150 to 200. Okay, so this chart is important, and our answer is option B, where B greater than A greater than C. Now coming to question number 7. The number of signals for the given molecule in proton and 13C NMR spectra respectively. How many signals it will be showing in proton NMR and 13C NMR? First we can see 13C NMR. I will draw this figure once again. So these two will be identical. We can name them A carbons. This will be B, C, D, E. So total how many signals? 5 signals will be the for 13C NMR spectra. Clear? Now how many signals will be the for proton NMR spectra? 4, yeah. Here there is no proton. In C region there is no proton. Hence it will be showing 4 different signals. One here, 2, 3, 4. This will be similar. So 4 signals will be the for proton. Hence the right answer will be option D. 4 proton signal and 5 13C signal. Right? Any doubts?
No, ma'am.
Okay. Now, coming to question number 8. The 13C NMR spectrum of a compound A contains two signals, and in the proton NMR spectrum there is a singlet. Which compound is consistent with this data? So here they have mentioned that 13C NMR spectrum it is showing two signals, and the proton NMR spectrum it is showing a singlet. So among these compounds, ethanol, dichloromethane, acetone and bromoethane, which will be consistent with this data. So we can draw the structure of each and compare that. Ethanol will be CH3, CH2, OH. So it will show two 13C NMR signals and two proton signals. These are different, right? So, two 13C and 2 proton, ethanol will show. So, we can rule out this option, dichloromethane, CH2, Cl2. So, it will be showing, it is having only one carbon. So, it will show one 13C and one proton signal. So, this is also ruled out. Now, if we see bromoethane, it is also similar to this ethanol. So it will show two 13C and two proton signals. If we compare acetone, CH3, double bond O, CH3. So these two will be identical. This. So it will show two 13C spectra, and in the case of proton, here the 6 protons will be identical, right? It is symmetrical compound, the 6 protons will be identical, hence it will show only one proton signal. So the right option will be acetone. Any doubts?
No, ma'am.
Okay. Now coming to question number 9. How many signals in proton NMR spectra will be obtained from the following compounds respectively? So, 4 different compounds are given. So, they are asking how many signals from the proton NMR spectra it will be giving. So, in compound A, how many signals it will show? Hmm?
Two, ma'am.
Compound A will show 2 signals. Compound B,
One.
yeah, it will show 1 signal. Compound C, compound C, how many signals it will show? We should think like it is symmetrical. So this will be identical. So this is A, this is B, this is also will be A, this will be B. So this is 2 signals. Third will come from here. This methane will be showing third signal. So we can label like C, and this methyl will show fourth signal. So we can label it like D. So compound C will show 4 signals. Similarly, you tell how many signals will compound D show?
2, ma'am.
Compound D will show 2 signals. So what will be the right answer among those options given?
Second option, ma'am.
Second option will be the right answer. So everyone got right how the number of signals are coming? Here, two signals will be coming, one from this methyl and this three methyl groups which are present in this tetrabutyl will be similar. So, one signal from here and one signal from here. And in tetramethyl all the methyl groups will be identical. That is why it will be showing only one signal. And here, as we discussed, because of the symmetry of this compound, these two protons will be identical, these two protons will be identical, then this methyl group and this methyl group, hence four signals will be coming. And in this case, this is also a symmetrical compound, so these two protons will be identical, these two protons will be identical, hence it will show two signals. That is why the answer will be option 2. Clear? Okay. Now coming to next question. Question number 10. Predict the product of the following reaction. Here a nitrobenzene is given and an alkyl chloride is given and it is treated with AlCl3. So which is the reaction that is taking place here? What is the name reaction that is taking place here?
Friedel-Crafts alkylation.
Yeah, Friedel-Crafts alkylation is taking place here. Here the alkyl chloride is there, AlCl3 is there. So Friedel-Crafts alkylation is taking place here. So what is the product that we will be getting? A. We will see. This is the hint. Because of the presence of this nitro group, this ortho position and para position will carry positive charges. So in our case, it is electrophilic aromatic substitution reaction. For electrophiles to attack on the aromatic ring, if aromatic ring is carrying a positive charge, that will not be possible, right? Reaction will not be possible. Here we can see this center is positively charged, ortho center is positively charged, para center is positively charged. So in these positions, the alkylation reaction will not be feasible. So the right option will be there is no reaction. Clear? There will not be reaction. Because of the electron withdrawing nature of the nitro group, ortho position and para position will be carrying positive charges, hence attack of this electrophile will not be possible. That is why there will not be any reaction in this case. Now coming to question number 11. Predict the product of the following reaction. This is also an example of Friedel-Crafts alkylation reaction, but the difference is it is an intramolecular Friedel-Crafts alkylation reaction. So what will be the product? Any guess? Let us see what is the answer. So this is the mechanism. First, this lone pair of chlorine will coordinate with AlCl3. Lone pair of chlorine will coordinate with AlCl3. We will get this intermediate. Then this will get removed and a positive charge will be generated here. Okay. AlCl4 minus will remove and a positive charge will be generated here. So this is a secondary carbocation. Okay. So there is a chance that if this proton is migrating, it will lead to formation of this tertiary carbocation. Tertiary carbocation is more stabler than the secondary carbocation, hence this formation is favored. Then this double bond on the this aromatic double bond will go and attack on this positively charged tertiary carbocation, and we will get this intermediate. Then for the regaining of the aromaticity, this proton will be abstracted, it will be removed, and this aromaticity is regenerated, giving this product. Clear? Clear? Excuse me, I will just connect the charger. Is the mechanism clear? Hello?
Yes, ma'am.
Okay. So the formation of the tertiary carbocation is the driving force for giving this product. Okay. So the right answer is option C. Now coming to the next question. Here anisole is given. It is treated with HCl in the presence of HCl and AlCl3. So what is the name reaction? What is this name reaction? aromatic aldehyde formation is taking place. So sir have discussed regarding Gatterman-Koch reaction, right? So this is an example of Gatterman-Koch reaction. So what is the product that we will get? What is the product that is forming? Anyone please unmute and say okay. So this is the mechanism. Both ortho and para product will be possible, but since more resonance is more favored, this could be the major product. Like this lone pairs will be shifting here, this double bond can shift here, this double bond will go and attack on the carbon of HCl, and this bond will break and it will abstract a proton from HCl. So we will get this compound, this intermediate. Then Cl minus can abstract the proton for regaining the aromaticity. So it will regain aromaticity. We will get this imine and it can undergo hydrolysis giving this aldehyde. So this will be the major product, but the formation of this product, that is ortho product, is also feasible, but it will be minor product. Okay. This is also feasible, but it will be minor product. Any doubts?
No, ma'am.
Okay. So our right answer will be option D, that is the paraaldehyde. Now coming to the last question. For the following reaction scheme, identify the reagents. So as we can see, this is Friedel-Crafts acylation reaction. So what is the reagents that should be used for getting this particular product?
CH3CH2COCl, ma'am.
Yeah. So along with AlCl3, then only this reaction will be feasible. So the option will be option C. We can see the mechanism. So we will get the acylium ion like this. The lone pair on oxygen will shift here. This will AlCl3 will coordinate with this chlorine. Lone pair of oxygen will shift here, and this AlCl4 minus will get removed. So we will get this acylium ion. This double bond on the benzene ring will go and attack on the carbon, and this positive charge will be neutralized. Then we are having a positive charge here. So for neutralizing that and for regaining the aromaticity, the Cl minus which will be removed from this can be abstracting the proton, and we will get this compound. Then this we can see the reagent given here is same only, that is zinc mercury amalgam and HCl. So it is a condition for Clemmensen reduction where this ketone will be reduced to alkane. So here it is happening like this. This will coordinate to this zinc surface and it will get protonated. Later water will be removed in the presence of H plus, and this will undergo like this double bond will convert into, it will undergo it will convert into saturated compound, giving the final product. So Clemmensen reduction it will be undergoing. Clear? We just have to be careful regarding this only, that is the Friedel-Crafts acylation reaction which we have learned. As you can see in the options, just the difference in this reagents is given for the Friedel-Crafts acylation reaction. So if you are clear about the Friedel-Crafts acylation reaction, you can get this question right. So are you having any doubts regarding the questions that we discussed today, or any doubts regarding the lectures?
No, madam.
Okay. So in this lecture, basically we have to be clear about the regions where the proton and the 13C spectra are coming, and we should be clear about the Friedel-Crafts acylation, alkylation, and the Gatterman-Koch reaction. So we will be able to solve the questions that will be given in the assignments. Okay. So if there are no further doubts, let's wind up this lecture. Thank you for joining. I will upload the lecture notes and the video in the link that is provided. Okay.
Thank you, madam.
Thank you, ma'am.
Thank you.
Thank you, ma'am.
Thank you,
Thank
ma'am.
you, ma'am.
Thank you.